Hi, I'm Elle, and I want to thank you for taking the time to listen to my presentation today. Before we start, this is the trifold presentation board that I created. However, for the sake of this video, I'm just going to be presenting with Google Slides. So I'm interested in finding affordable ways to get clean, safe water because all around the developing world, bacteria in unfiltered water can create a tremendous burden of life-threatening illnesses and diseases. So I conducted this experiment to establish the best method to easily make water safe. I researched several different types of decontamination, including filtration through a coffee filter, boiling, chlorination via bleach, and solar sterilization. My hypothesis was that boiling water would kill the most bacteria, and my null hypothesis was that there would be no change between the groups. So each level of independent variable had 6 trials, and the dependent variable is amount of bacteria per milliliter, and some of the constants were the amount of water, the same testing day, the same incubation period for the test strips, and the disinfection of all materials prior to testing. So these are a list of just some of the materials I used. So prior to experimentation, all containers and bags for testing strips were labeled with the given group and trial. Then all materials and equipment were sterilized. And with one large bucket, I collected 3 liters of stream water. 500 milliliters of water was put in a flat glass baking dish and covered and then left in the sun for 6 hours. Then 500 milliliters were cooked on medium-high until they hit a rolling boil and then left on this rolling boil for 2 minutes. And using a ratio of 1 drop per 500 milliliters, household bleach with 6% chlorine was added into the water via a pipette, and this amount is still safe to drink. And lastly, a coffee filter was secured around the top of a container and 500 milliliters were strained through. Then 30 Waterworks bacteria growth check test strips were dipped into the 5 containers of water, and these strips were then sealed into individual Ziploc bags and left to incubate for 48 hours. Then they were evaluated with the given key after the 48-hour period. These are the mean results for each group. The indicated orange breaks scale the graph accordingly to make the information easier to absorb. And as you can see, the control group had the control group had 340,000 bacteria per milliliter, and the coffee filter and sunlight groups had a little over 167 million bacteria per milliliter. The boil group had 83 bacteria per milliliter, and the bleach group had 50 bacteria per milliliter. The chart on top indicates averages, standard deviations, and individual t-test results for each group, and the bottom chart is my raw data. And this top chart is the ANOVA results, and below are just the individual p-values again. So with an overall p-value of 0.000, the data can be determined to be statistically significant, and these findings can reject the overall null hypothesis as the boiled and bleach groups had notably less concentrations of bacteria. The p-values of the boiled and bleach groups were both very significant as they were well under 500. But on the other hand, the sunlight and coffee filter groups were not significant, with both of them having more bacteria than the control. For the coffee filter, there could have been extra bacteria within the filter itself that further contaminated the water when it was getting strained through, which would explain why it is higher than the control. And an uncontrollable variable in any circumstance is the weather. So that means that UV light is not always reliable. And since UV light takes time to purify, with a minimum of 6 hours to be considered safe, if these solar rays aren't properly reaching and killing the bacteria, then this bacteria just has more time to reproduce and proliferate. So that's why the sunlight group has a higher concentration than the control. But overall, the bleach group was the most effective method with the lowest amount of bacteria, and the boil group was the most consistent with the lowest standard deviation. Boiling the water works because the use of heat damages the structures inside the bacteria and kills it. And putting a drop of bleach in the water works because the hypochlorous acid damages the structures of proteins inside the bacterium and causes it to die. And although results say chlorine is more effective than boiling, I think that honestly either method would be best to safely remove the bacteria just because of how close their data is to each other and how astronomically different these data sets are in comparison to the other 3 groups. And these are some of the photos that were on my board. Thank you.